according to howstuffworks.com. And based on Wikipedia, astrophotography is photography of astronomical objects. Like what you see inside, these are actually astronomical objects. Celestial events and areas of the night sky. Areas of the night sky, like what we see, Milky Way, very popular constellation. Whether that's the Big Dipper constellation of the north, or the Crux at the south, or the Orion Nebula, the Orion Constellation, which is now on the west, or the Scorpius Constellation, which is actually rising from the east at this period. And astrophotography has the ability to image objects invisible to the human eye, such as dim stars, nebulae, and galaxies. This is done by long-time exposure, since both film and digital cameras can accumulate in some light photons over long periods of time. So, as you can see on the Milky Way shots over there, we don't know that actually there's Milky Way on that part of the sky. We will not know it until we do long exposure. We cannot do 1 second exposure, 2 seconds maybe can, but at least you are in a dark sky, but not in the city. So that's astrophotography. So to illustrate this, everyone is familiar with this constellation. It's called the Orion Constellation. At this moment, Orion Constellation is actually setting on the west right now. Now is 7:10. I think it's somewhere over here. Actually, before we planned this event, we were checking the forecast, but tonight it's actually cloudy. Because if it's not cloudy, we can actually show you where that constellation is. But this is the very popular Orion Constellation, or the Hunter. So if we take a look on just our bare eyes, we see this constellation. So we have these stars. Well, I'm not gonna mention all the names of these stars, but of course we know this 3 stars over here, and then the arms, and then the feet. So just with our bare eyes, this is what we can see. However, if we would take a DSLR, for example, let's say a 5-minute exposure or 6-second exposure, a DSLR and a simple tripod like this, we can actually see more stars. We will be able to see more stars. And take note, in that moment, actually you will see this part of the constellation here. That is actually a nebula. On our bare eyes, even in Phnom Penh, as long as there's no too much haze, we can actually see a nebula. But for us, that nebula is small, so that's why it appears to be just like a star, but actually it appears here. That is the Orion Nebula. So as I mentioned earlier, what do we need in astrophotography? So we need images with long exposure. We need a tripod to prevent the camera from shaking. Of course, imagine this tripod over here, or when you are shooting with the tripod, if someone accidentally tip off on one of the feet of the tripod, what happens? The image that it took will kind of blur, right? So it will be the same like stars, but with stars, it's terrible. You won't see stars anymore, but you will see like a fly moving on your screen. Okay? And also, we need a remote shutter to prevent the camera from shaking. Again, to prevent the camera from shaking. So this can be an intervalometer, or maybe your cell phone. I think for Canon and Sony also have that, but for Nikon user like me, we have what we call the WMS app. We can control the exposure and shutter. And of course, after taking images, and by the way, we don't take one single image, so we can get a better detailed photo. We need multiple pictures, and we need a computer to process them. And this topic will be covered on future sessions, but for the sake of completeness, we will be mentioning this process. It's the process called stacking. Stacking is a process of putting images together so you can see more details and eliminate some kind of noise on the photo. Every camera is not 100% perfect because a camera and its sensor will have some kind of a heat, and that heat is translated into noise. Oh, by the way, the noise is actually like a pixel or an unwanted color on your image. That's a noise. Okay. Yeah. So it's a commonly used term to describe visual distortion. So it looks similar to a grain found in film photographs, but can also look like splotches or discoloration when it's really bad and can ruin photograph. Noise tends to get worse when you're shooting in low light. Yes, so for example, I think I can give one example. If you are a bridge camera user, wait, actually just very basic, just cell phone, okay? If you use, for example, like me, I'm an iPhone 6 user, okay? If I take a photo during daytime, it's quite good. The contrast is nice and the image is smooth. But if I take a photo of somewhere dark, if I take you can try it later on, your picture or your image will look grainy. And that grainy thing is actually the noise. Okay. So again, we can go back to this constellation. So right, so if we expose our DSLR like this in just a tripod, we can see more stars in there. But this constellation actually hosts three famous nebula. As I mentioned already earlier, I don't have a pointer, but here, that's called the Orion Nebula. Okay, and here's actually a magnified image of this area. So this is the Orion Nebula, and there's actually another nebula here. And there's a reddish patch here, and that is actually called the Horsehead Nebula and Flame Nebula over there. Don't worry, you will see a bigger picture of this later on. So now, this is a higher magnified image of this part of the constellation. So this time, the gentleman who took this picture used a longer focal length lens. Okay, again, we're just on lens. So the Flame Nebula over there on the left and on the right, as Horsehead, is more detailed than the other one. So they used to picture this using a star tracker. And what a star tracker? So now it's not just a tripod. So they put the camera on the star tracker, and that's an equipment used to automatically track astronomical objects on the night sky. It rotates at the same speed as Earth, but in just opposite direction. So if Earth rotates that way, so this is east, so the star tracker moves on the opposite. So that's what a star tracker does. Why? Why do we need a star tracker? Because again, the Earth rotates. And you need to follow the stars. So the stars on your images will be pinpoint. Otherwise, what you will see is just lines of stars. Yes, so that's what will happen. So without a star tracker, your stars will look elongated. So that's the difference. Normally, we use a star tracker if the lens is quite long already. So for example, for a 50mm lens, like I showed as an example earlier, 50mm lens, we can still go for 3 seconds or 8 seconds. But we cannot do 15 seconds, or maybe some can, but 30 seconds definitely we cannot do anymore. Because during that time, the rotation of Earth is now faster than what the lens can catch. So that time, we use a star tracker. Okay? And now, this is a bigger image of actually this part of the constellation. So again, it came from here. That's the Orion Nebula here, right? And then a little longer focal length, it became this one, more detailed. And then, now, when we use a bigger telescope, we can see it more detailed. So that's the same as Orion Nebula on the top. And this time, I use, this is my telescope, by the way. This is actually a 2000 millimeter telescope, but I use a reducer, so that's why it became 1300 millimeter equivalent. So, well, yeah, this is a picture of me in 2019, same year when I started. Okay. So now, what are the imaging devices? So if we sum it up. So actually, we can do smartphone. Yeah, believe it or not, smartphone. We have a compact camera, like the bridge camera, with a built-in zoom lens, DSLR with lens, and also, of course, a telescope setup. But please take note, smartphones. As long as the smartphone have manual mode. Manual mode meaning you can control the ISO, the shutter speed. If you can control that, then you can actually do picture the night sky with longer exposure using a smartphone. Okay, so again, as I mentioned earlier, this presentation is actually available on my Facebook page. You can actually see it later on. But this table actually shows the different kind of imaging device, smartphone, compact camera, DSLR, telescope, and what kind of astronomical objects we can catch. Okay? So, for example, constellation and star trails, these are big. So we don't need a telescope on that. So again, there are smartphone, compact camera, and DSLR is okay. Milky Way. Milky Way is very big. Milky Way is actually not just what you see there on these pictures, no. Milky Way is actually around us. Because Milky Way is a galaxy and Milky Way is where we are in. It just happens that the Milky Way that we're seeing now is the core and that's the brightest part. So where actually there is a black hole, okay? Or the biggest black hole of our galaxy. We can also capture celestial events. What are celestial events? Moon phases. So, for example, now today is 29th. So it's nearly new moon. So new phase. 2 weeks ago it was full moon, right? So we have a first quarter, half, and then the last quarter. Lunar eclipse. Okay. Lunar eclipse is quite sometimes only in our location, but actually there are several lunar eclipses, but it just happens or pointed on different part of the globe. Lunar transit and occultations. What's a lunar transit and occultation? Lunar transit is actually when another celestial object actually passes near another object. So for example, let's say this is the moon, and then we will see another star that crosses near to it. Normally, that will be Mars or Venus, which is actually, it appears to be like a bright star, but actually these are planets. We will see this later on. Planetary opposition and conjunctions. Okay, I think, again, this table is available on my Facebook page with that presentation. So it's laid out here so for everyone to see. But for the sake of making this presentation more brief, at least I presented you how the table looks like and what does it show. Okay. But there is one part here that I will suggest, recommend, and I would like everyone to take a caution of. Okay. As you may know, I have 3 imaging devices for astrophotography. But you will not see me shooting sun. Why? We only have one pair of eyes. Sun is very bright. If you point it into a lens, it's very bright. It's either you damage your eyes or you damage your sensor. Okay? So, however, solar photography is actually possible also, but there's a dedicated equipment for solar photography. It has a special filter and it also has a special kind of lens. So for a more detailed solar photography, you can actually either use a telescope or if in terms of DSLR lens, actually I think about 600 millimeter equivalent lens you can. But again, solar imaging is very dangerous. You need to learn how to use it first before operating it. Okay. By the way, on the part of the presentation here, you will also see some images of solar photography. Okay, so now showing you some example of smartphone. Okay, so this is the Orion Constellation like last time, taken with a smartphone. Star trails, yeah, you can do it again as long as you have manual mode on your smartphone. Milky Way, actually one of our exhibitors is absent today. His name is Sarewat. You can see his Facebook page. He has done a very terrific job with utilizing his cell phone, and he can shoot the Milky Way just using that device. As I mentioned earlier, Lunar Faces. This is a composite image, adding all these faces in one image. This is actually, this image actually consists of the moon. It's just quite not that good in resolution, but this is Jupiter and this is Saturn over here. Is it Jupiter? Yeah, it's Jupiter and Saturn over there. So see, we would not know that one dot of light in the sky. We thought that it's just a star, but actually, you won't know that some of the objects there are actually planets themselves. Okay. Now, just one trivia. Okay, one trivia. Aside from using an app, okay. Aside from using an app, because Android or iOS already have some sky maps, okay? If a particular star is actually blinking, okay, there's more chance that that is a star. But if it's not blinking, that is a planet. Why? Because this star is very far, so it appears small, okay? And the atmospheric turbulence and atmospheric conditions will kind of how do you call that? Not vibrate, but it will somehow appear to shake the image. So that's why you will see it appears to be blinking. Okay. However, a planet is quite closer and bright, so it won't be affected too much of this atmospheric turbulence. Mhm. So that is a test, okay? However, some nights, for example, Mars or Venus, sometimes they twinkle. It means that the turbulence in the sky is too much. Normally, if it's windy, okay? It's windy at the bottom and it's too much turbulent. Okay. Yeah, so again, just using with a smartphone, but this is pure luck, I tell you. A bolide. A bolide is an extremely bright meteor, especially one that explodes in the atmosphere. So we see a meteor that's very fast, like less than 1 second. But this one is different. So this one is more brighter, and it just exploded at the same time in the atmosphere. But this gentleman, who's just again using a smartphone, was able to capture this astronomical object. So again, this is pure luck. Okay, and this is actually a meteor. This one, comet. That glowing part over there is a comet actually. So as you may notice, right? And as you may notice later on in the presentation, different devices can capture different kind of objects on their different field of view, but also you may notice the quality. So from there, you would know what you would expect on each imaging device. So again, Moon, this is actually, they use Huawei with this, and this smartphone have a zoom function. so it can capture the full disk of the moon. Okay, another trivia. Sometimes you will see the moon white and the moon yellowish. Okay, the reason why is that because I tell you, you cannot see a moon up top that is yellow. It will always be white. The reason for this, as it goes down into the horizon, okay, it is affected again by the atmosphere, so it will turn yellowish, or sometimes it will be reddish, right? So it depends on the atmospheric condition in that part of the horizon. So, and mostly, as you may notice, we will not just see a yellow moon during full moon. Sometimes on the quarter moon, we will also see that it's yellow. It means it's either the haze or the pollution on that area is quite worse. That's what it means. Okay, another star trail, smartphone, and this is a collection. So again, this presentation is available on my Facebook page, and then you can take a look. And yeah, believe it or not, this gentleman was able to shoot Jupiter. But how did he do it? What you call this? Planetary photography will be part of our last session, which is the 5th workshop by the end of April, during the end week of April. And I will explain later how he was able to capture this. He used a simple telescope and used a smartphone to record it. Okay, another constellation. No, this is a compact camera. So as you may notice now, the image taken by a compact camera starts to have a better resolution and better image quality. So again, if we want to get more serious on this, we can actually start to use this kind of devices. So, but again, we can start on phone as long as you have a manual mode. So, okay, so this is actually a conjunction. The guy was able to capture a waxing crescent at the same time during that night was Venus and Mercury. Okay, and this is an image of the moon. Okay, now we go to DSLR. I showed this earlier already. Okay, and Milky Way nightscape. Again, not using a telescope. The gentleman used, I think, a 600 millimeter zoom lens. And a DSLR. Okay, and some deep sky images. The blue one is Pleiades, and the green one is actually a comet flyby during that moment. Again, a moon. Okay, this image here is actually a solar photography, but this time he captured the solar eclipse. I think this was 3 or 4 years ago. So he was able to make a collage of all the faces from the full disk until the ring, and then until the moon went out on the view of the sun. So solar eclipse. Okay. Again, a DSLR. This is the Rho Ophiuchi. Okay. Okay. So now this background. This background is actually part of the Milky Way. Okay, but it's somewhere at the south. Okay. So I took this in May of 2020 when COVID hits our country. Okay. During this time, actually, I took it in Tulkok. My house located in Tulkok. So this is my camera over here. It's quite dark. Okay, but that's the screen of my camera. During that time, this is Jupiter. It's pointed towards here, and this area is actually Salatecno. This actually is the area of Salatecno. So I took 100 images, more than 100 images of 3 seconds each using a 50 millimeter lens, and that's what you see on the background. So again, not necessary for a telescope. You can use your simple DSLR camera. and take little more longer exposure and more images and stack it together. Okay, telescope. So of course, if we can shoot it with a smartphone, with a bridge camera, with a DSLR, why not telescope, right? So this is actually a comet flyby. Moon, of course, Mars, Jupiter, and Saturn. Okay, so again, on the fifth part of the workshop, I will be providing raw data of these astronomical objects, and you will process it the same way I did how I processed this, and the moon. The Mars, if I can still find my file, we can try to test it. Okay. But again, on this fifth workshop, we will not be using like NASA data. Okay, it will be our own data. Yes. No questions so far, right? Okay, let's go. Yeah, I showed this earlier already. So, well, I think that's basically it, right? We actually have this part of the presentation, but we already did that inside. So I think this time we will skip on this. Okay.
It's the same as the DSLR settings anyway.
Yeah.
Like manual mode on the phone.
Yeah. Yeah, and the same pictures here are actually shown inside. So.
Oh, is it?
Yeah, it is.
Oh,
yeah, see.
Oh yeah, from
Marty. Yeah.
Marty is like DSLR, but
DSLR, yes.
That's my face.
That's your face and that's your red cat. Okay, so yeah, I'm gonna be a little fast with this. I explained this. Oh yeah, this. Oh wait. This one is good. This one is a good example. Okay, again. Imagine the Orion Constellation earlier, right? We can see just about 7 stars or less than 10 stars. If we use a DSLR and long exposure, we can see more stars. However, this is what you will see if you are in a dark sky. Okay, I'm gonna show it to you later. Oh my God, I think it cannot be seen on because of the brightness of the presentation. Okay, anyway, you can take a look at my Facebook page. You will see a different kind of Orion constellation there because it will show a red nebula over here, and then another red circular nebula on this part. Too bad this presentation cannot see it, but in a dark sky you will see more details. Why we can see more details on the night sky? Because there's no more light pollution. What is light pollution? Light pollution is just simply this, like what we see right now. It happens that it bounces into the sky and illuminates whatever thickness or however thin that cloud is. Okay? Now, I think a lot of people here are doing some camping, right? Who does some camping? Okay, all right. When you go camping, this is a difference that you will see. When you go camping, if there are clouds on the sky, you will not see it white. Yeah, you will just see it as black. You will just know that it's a cloud because there are some stars that peeping out of this area, yeah? But in Phnom Penh, the cloud that we will see will be white. Why? Because that white is actually the light of the city. So the same with astrophotography. If you don't have the right filters or the more, how do you call this? If you are not on the right area, okay, of a city, you won't be able to see dimmer images. Otherwise, the brightness of the clouds or the sky itself will eat up these details. So yeah, so that encircled area there, is actually this M42 or the Orion Nebula image. This is actually one of the best Orion Nebula image that I saw that was taken in Cambodia. Okay, not by me, not by Nara, but by another astrophotographer. Okay. Yeah, and this was taken for 4 hours, right? Okay. So just a trivia, okay? Just a trivia. This Orion Nebula, the reason why it's so bright, because this is a star-forming region. This consists of gas, and in this part of the area, stars are still forming. Astronomers see it and observe it that it is still forming stars. Okay, so yeah, so this image is actually inside also, and I also explained this earlier already inside. So this is a 50mm lens, and this is, by the way, my setup. Okay, so this is a star tracker. This is the 50mm lens, and I have the dedicated camera. So as you can see, I'm just in the city, but I use a filter for this one to capture the image. And this is my bigger astrophotography rig. So a bigger mount and a telescope, so I can see and capture that nebula. Okay. So this is actually a file that I want to share. Okay, and I want to show everyone. How does it? As I mentioned earlier, in astrophotography, we take multiple images, multiple pictures, but with long exposure. And again, why do we take multiple exposure? Because of this. As you can see, this is actually the Rosette Nebula, the same Rosette Nebula that you will see inside, like the rose thing. This is what a 10-minute exposure look like. So it will have a lot of noise. These are actually noises. This thing here that you see, these are noise. And then the nebulosity itself that you can see, yeah, it's quite detailed, but it's not much. Okay? So the process of stacking is actually taking out random noise and leaving good signal remain on your image. Yeah, Mr. Campbell.
Do you have a picture example of the single photo?
Yes, single photo. Yeah,
Yes, sir.
not yet stacked. Yeah, this one is a single photo. Yes, not yet stacked. This is a raw file. This raw file is actually taken from my image acquisition device. So this is 600 seconds and gain 200. And in a camera like that we use the term gain rather than ISO. So gain is equivalent to ISO. And as you see there, this hyphen 0.3C, that's the temperature. Okay. The difference between a dedicated astronomy camera and a DSLR is just actually the major part is cooling. So again, the longer the exposure you get, the sensor will build up some heat, and this heat translates into a noise. So that's why astrophotography is actually more long exposure. So that's why it's better that your sensor is cooled, so you get lesser noise. Hence, you can get more signal, more good signal. Okay. So yeah, this is my 400mm telescope. And I'm shooting from the 9th floor of our house. See the light pollution there. I mean, it's very, very bright. So, yeah. Yeah, just more sample photos. But during this night, I was with Nara. Where's Nara? Nara is over there. And during that time, we tried to capture the comet flyby in January. Nara, that was January, right? December. Comet Leonard.
I think it's the song 22 this year, yeah.
Yeah, this year. So this is actually the Comet Leonard. Yeah, that's the last picture, and this is my picture. Okay, so I think we can conclude the presentation. If there's any more question from the audience, but again, if you have questions, whether it's not on the presentation today, it's okay. As long as it's part of astrophotography, not astronomy or astrophysics. Okay, we can share. But we have 4 sessions coming, which is scheduled every 3 p.m. on Saturdays. You can visit our event link and register, so we know how many people are coming. Okay, so yeah, questions? Yes, please. Nara, question? You got the mic? Okay. Here. The one under. Long press. Until it turns green. Yeah.
I see one of the photo of Orion Nebula, and I see that the color in your picture and inside is different. Tell us why.
Okay, very good question, and you have a very good eye with that. Okay. All right. Okay. Actually, you can see the event link. The picture on that is actually Orion Nebula 2. The poster that you see there, the whitish one, that is also an Orion Nebula. Okay. Now, why is it different? Goes to your question. Actually, even the Hubble Space Telescope, if they take a photo of it, it will just become whitish, unless they use specific filter that will separate the gas emission. For example, what is common: hydrogen, oxygen, sulfur, and then when they combine it together, they tend to adjust the level of these colors. When they adjust the levels of these colors, now it depends on the photographer himself, and there where art comes. The art comes on your choice. What color would you like it to be? But normally, putting colors on it makes the image pop up more, not just because of art, but scientifically as well, because you want to distinguish, you want to know which one is hydrogen, most likely, which one is oxygen, most likely again, okay, or which one is sulfur emission, okay, as it appears, okay. So that's why you would see different colors of a nebula. I invite you to take a look. You can type it on Google, Astrobin, Astro bin and then bin.com. This is a website of other astrophotographers where they put in their images there, and you will see a lot of color palettes. Okay, so yeah, but it's just the same. So now it becomes part of the artist on his taste. But I mentioned it inside earlier. Astrophotography is quite challenging in terms of it becoming an art, because at the same time you want it to balance becoming artistic and not going away from the science itself. Okay, so for example, it will not become science anymore if you add other objects over there. Okay, or for example, just an example, let's say outside. Okay, outside, we're facing west here, that's east, that's north. Just one example why it doesn't become scientific. You pointed or you shoot the Big Dipper. Everyone knows the Big Dipper and the Small Dipper, which is on the north, right? And then you place a full moon on that area. That's no longer scientific, and it's no longer astrophotography. Okay, astrophotography preserves the science behind it. Okay, and not going too much on the art itself. And normally, saturation helps to boost the structure of the image, to see the distinct structure of the image. Okay, All right, that's a very, very good question. Thank you. Anything else? Oh, by the way, if you want to ask question in Khmer, Mr. Nara here will gladly answer it for you. Anyone from the gentleman at the front? Any question?
Yeah, maybe. Which type of filter do you use on DSLR?
Sorry?
You, you talked a bit about the filter that you use.
A filter,
Okay,
yeah.
Which type of filter do you use on DSLR? Some to filter the city lights, or do you use other filters to bring colors?
Okay. Thank you for that question. Okay. Question is quite advanced, but it's okay. So for me, I use two kinds of camera. A dedicated astronomy camera, which is the temperature control, and a DSLR. So for DSLR, I use a light pollution filter only. Okay. We also have what we call the narrow band filter. So for the sake of everyone, a narrow band filter is actually a kind of filter that will only let in specific wavelength of light. So okay, for example, imagine a rainbow. Okay, rainbow has 7 colors, seven major colors. Rainbow, right? A broadband filter or the light pollution filter will actually let most of the 7 colors in. But on some colors, it will block like 30%, 20%. So that's a more lighter light pollution. Now, when I mentioned narrow band filter, for the sake of completeness, for the different kinds of filter, like what I use inside, if you want to shoot the red part of the rainbow, which is mostly hydrogen, then you just use that part of filter. Yes. Thank you. Okay. Any other question before we end tonight's session? Question, bro. Mr. Soy Sokara.
Just want to ask you about what is different between rule 500 and NPF rule.
Sorry?
What is different between NPF rule and rule 500?
400 rule?
500
500 rule?
and NPF.
NPF.
NPF rule.
NPF rule. What's NPF, by the way? What's the abbreviation of NPF? I have a lot of abbreviations in mind. Okay, please help me out. Okay. NPF. Wow, that smells. Okay, wait, I'm gonna take a look at that with you as well. NPF rule.
NPF rule. Yes. This one rule.
Okay, I got it. Common rule, program to figure out maximum shutter speed. Okay, all right. Yeah, thank you. Actually, I think I saw this NPF rule sometime on some astronomy forums. But I think it's just the same as like if you're gonna use the 500, 600, or 400 rule. Okay? But let me share to you a rule that rules them all. Okay? So this is a rule that rules them all. I don't even use 400 or 500 rule. Why? Because if I stick on following this 400 or 500 rule, I will just get confused, especially as a beginner. Why? Why based on this rule? If I use 400 rule, I will not get star trails. I'm supposed to get pinpoint stars. Now, this is the rule that rules them all. The triangle exposure itself. Okay? Using a DSLR and a tripod, simply do like this. I can share you later on Facebook, don't worry, okay? And this is the same thing that I shared to Nara last time. First step, okay, shoot your target, whether that's a 50mm lens or 135 lens, shoot your target, just shoot your target. Maybe 3200 ISO, go for it. Start. Now, once you take a shoot of it, so you will see that the stars will trail, right? Or maybe 1 second, 2 seconds, doesn't matter. Now, after the ISO, you gradually increase your shutter speed. Okay? Increase your shutter speed. 3 seconds, 5 seconds, it's still circle, it's still pinpoint. Okay. Step up. 7 seconds, go higher again. 8 seconds, 10 seconds, as long as the star is pinpoint. Now, if you see the star will a little bit trail already, let's say 30 seconds, then stop. So why I say like this? Because on different setups, you have different, let's say for example, you have different quality on your tripod. You may have a different quality on the wedge or how to put it or to point it. The 500 rule or 400 rule doesn't apply because on the physical capacity of your equipment. So again, start with the basic, the triangle, the exposure triangle. Now, let's say you got the 30 seconds. Okay, fine, 30 seconds, I got it. Okay? Of course, this 30 seconds in case you use intervalometer, okay? Because definitely it will shake if you just press it manually, okay? And your tripod is sturdy, okay? So after you see that 30 seconds is the most exposure that your star will not trail, then go back to your ISO. Why? Because your 3200 or 3200 ISO may have a different brightness now if you go 30 seconds. And again, noise. Yes, or histogram. Okay, you can check your histogram to make it easy, or it's up to you. If you think the noise is acceptable, then just go for it. Okay, but the 400, 500 rule actually also apply. Why? Because it will give you like at least an estimate. Okay, it's an estimate rather. For me personally, I would prefer it as a reference only. Okay, how much can I get? Okay, so one example, I use mostly 50mm lens. So if I follow the 400 rule, I will have 8 seconds. Yeah? Oh yeah, is it correct? Yeah. 800, yeah, okay. My math is quite trash during tonight. Okay? So, but for me, that's just a ballpark figure. I will still based on what I have. Okay? So that's what I advise. Anything else? Sam? Question? Okay, all right. Any more question? Otherwise, let's call it a night and enjoy the evening. Or we need one more.
Hello. I might have one more for you.
Okay. Come on, just SMS it to me. It's okay.
Like if you use a tracker to shoot the stars or anything, what's the difference if you shoot the sun, the moon, and the stars? Is it like the same speed or different speed on a tracker?
Okay. Good question. That's advanced. I never thought you would just ask it to me personally. Okay, that's fine. Okay. All right. The speed. Okay. Tracker and mount have its speed. It has different speed. Okay. There's a lunar, sidereal, or solar. I think I forgot, but because I don't use that, I mostly just use lunar and
But how about
sidereal.
comment? How about comment?
Okay, all right. Here's the catch. Okay. Different tracker have different kind of speed. Okay. The speed will now depend on what astronomical objects you will shoot. Okay. Stars are actually a farther astronomical object. Okay. So basically, that will be different if you shoot the moon. the moon is actually moving it appears to move fast on the night sky than other objects,
Yes, yes.
even faster than the planet itself. Or the closer the planet, the faster it appears to be moving, and then the farther it is, like that. That's one thing, okay? But there's another thing. How fast you would set the tracker. The speed of the tracker can also be useful if you want, if in advanced astrophotography, you would need guiding. So the speed of the tracker will help on your guiding corrections. So, yes, okay.
Workshop.
Workshop. But that should be on the second season, not episode but season. And this month is the first season. Okay. All right. So, however, I hope I can answer that in more detail. But of course, my my knowledge with astrophotography is not that big. So we're just trying to share what actually we have learned between our friends over here, and also what I have learned while I am trying to start with this hobby. Okay.
Sorry. One last question.
It can be more questions. It's fine.
Okay, so my question kind of opens the door a little bit to a lot of dialogue. They say that we only discovered about, 3%, 10% of the ocean, and that the universe, right, the atmosphere, out in outer space, even less than that. That's crazy. And every light, right, every single piece of white that I'm seeing is a star or a galaxy even, right? Right? So there's like millions and millions of possible planets
Yes.
that people could live on, right? It begs the question, what is your view on the concept of other life out there?
I love that question. Okay. Mhm. Yes. Okay. So the question is,
Yeah.
are aliens real? Are UFOs real?
Yeah.
Okay. I mean, all these extraterrestrial
Yeah.
things, right? Okay. I wish I can see one. But so far, for 3 years in this hobby, I'm so bored I wasn't able to see one. Okay? But here's my view. Okay? UFO, no. But intelligent life form rather than aliens, intelligent life form, yes. Why? Okay? Because if it's a UFO, how long would it take for an intelligent being to produce this kind of technology to even beat the speed of light? For example, Andromeda. To be honest, I don't know exactly how many light years that is, but at least I know, right? It's more than 1,000 light years. Nara is shooting Andromeda already.
It's the nearest galaxy to Milky Way.
Yeah, you reckon the distance, right?
No.
Okay, so see, right? Even before they can discover that kind of technology to have even on the speed of light, or let's say half of the speed of light, their sun or their star may have been turned into a red giant already, or may have been exploded. So that's my view. So no UFO, not for UFO, yes for other kind of intelligent beings.